Welcome to the Betikrame YouTube channel. Today I will describe how we identified as well as solved the gas turbine driver unit fault. In our gas turbine, we found that in normal condition the IGV position is showing 99.94%, that means full open, but our command is 0%, so it is not normal condition. And also we found that different alarms exist, and we identified what's the problem. You see, this is opening condition at the turbine stop condition position. This is the alarm. Different alarms exist here. IGV position error high. This is showing here. You see, this is the position. And also we found that from our block diagram, you see, this is the different position. Here is showing the condition. In the field we found that the actuator is not properly opening, and from our server we applied different signal, but the IGV is not working properly. That means it is not working, opening and also closing. So we take a decision to interchange the driver unit of the IGV. And in our store there is a new IGV unit. You see, this is the IGV and it is its inner side. And in the field we opened, this is our new one. Here is the connection, this is opened, and this is the old one. This unit is to be opened and it is to be connected with this one. This is the old unit. Inside this unit it is to be opened and this unit to be connected to the new one. This is the IGV position. You see, here is the position, and here is the IGV driver unit is to be connected with the help of a bolt, and the inside of the driver unit is opened. This is the move controller. IGV here is manufactured by Moog. You see, this is its nameplate. And at first we need to open this unit, and then we need to insert this unit to the new one. Very cautiously we opened this pin from this old unit. You see, this is as like bush, and open this unit from the old one, and now we will insert this to the new one. Now it is inserted into the new one. Now it is connected, it is free. You see, this is free and it is to be connected in the field. And manually we checked that everything was okay. After that we connected these units to our driver position, that means inside the gas turbine unit. Here is the connection, and the nut is connected with the bolt. Then after we inserted this driver unit here, you see, this is position and this is move controller. This is the control unit of the IGV. It is okay. You see, motorized valve actuator on fuel gas system. This is the controller. From our control room or from our server we applied signal, and then the signal comes to this controller, and this is our move controller inside the field. this controller was not functioning properly. This is move controller version 42. Here is all the connections. This is our ampere meter. It is showing 3.92 milliampere. Now we'll check in the field by applying the reference value. You see it is rotated. This is the degree. We applied command and we followed that. It is rotating. You see here is likely -40, and now we applied the signal value to 50 and we will follow that. It will rotate its mid value or not. Now we will set 50%. You see this is our 50% value, and here is showing likely 26 -26. It will be our mid position. We are applying by setting different value. Now we will set 75%. This is the actuator arm. It will rotate. You see this actuator is working and signal comes from the move controller. This is at 75%, likely -11 position. Now we applied 100% open and we follow what happened. Now we apply from our DCS 100 and here we will follow what's the output value. Here is, now it is +4. It means +4. It is showing. This is the rotating angle and it is the indicator. This is the indicator and this is the connecting arm. The driver unit when act, then this arm rotate and its position is changed. In this way we checked the IGV is working or not. And on the other hand, when the IGV is full open, then again we reduce our demand value and from 100 to 0, and we followed that. It was also working properly. And this is, here is some mirror error. Now we will set our command 0 and we will follow that. It will come to its initial stage, and you see this is our initial stage, and you see here is at 0 position, here is -52. That means -55 to +5 degree. After changing in this way, we checked our IGV function okay or not, and we found that everything is okay. In this way we remove our fault position, and and this is our ampere meter. We applied signal for a maximum and minimum value. Here is 20 milliampere, that means 19.93 milliampere when the output signal is 100%, and this is 0% likely 4 milliampere. Here is showing 3.84 milliampere. From this controller the signal goes to driver unit. After connecting the driver unit, we checked the IGV unit is working or not. From our DC system, we opened our system. This is our server unit. We will open the system. Toolbar ST. We are opening the software toolbox ST, and from here G1, and from G1 system double click here. Now the software is loading, and you see now connect G1 controller to our, and now find inserting the tag of the IGV unit. Now it is showing different blocks. From here we will open our required block, IGV block, and here is different value. This is output and this is our demand value. When we will insert the demand value by force, then it will show the output value, and also here is the degree, that means rotation value. We followed that. Here is no alarm and everything is okay after changing the IGV unit, and it is showing 0.78. If the difference is more than 2%, then alarm come. Now it is within the range. And now if we insert a value, you see here is 20% and this is force value, send, and here is some mistaken. We give the value here, you see is 20% open. This is our block, this is output, IGV position demand, and this is our input, AC degree, and also IGV position demand. When the IGV will open, then it will rotate at an angle, and here we can see this is the IGV position feedback, and here is no alarm, everything is okay. You see there is green signal, driver generic fault is not available here, and here is showing minus 0.78, that means almost close position. The demand signal is 0. Now we will set, that means command a value, and we will found that output will okay or not. Now we insert a value 20 and force applied, send, and you see here is also showing 20% output value, and here is 19.20. Error is within the limit, and here is showing the 20%, 19.78%. Everything is likely working properly. Output value 20%, and also in the field we check that everything is okay. When we unforce the value, then it's again it will come to 0. It is force value, so 20% is here showing. It is 20% force value is already exist, and here is 90.29%, and output force, if we force value the output, then also output will show this value. So if we insert this inside, it will work within the controller, and we set the value at output, then from direct output will active. And also we will set the demand value, IGV position demand. If do not set the force value, then it will not work. And now we set again 30, and you see here is 30 value, and when this value is applied, here we see an alarm. Here is showing 30%, but an alarm is exist here. Now if we again change this value, now we will set here 80, and if we set, you see here is also showing 79%, and here is also showing 79% valve opening. That means it is okay. And again if we change this demand value, it function okay. Again we can change this value. Here we set here 96%, and also the output value is 96%. Here is also 96%, likely 95 point something. Here is some alarm. This fault is not related to IGV. Here is the alarm for vibration. For sometimes some alarm comes from field, and if we reset this value, then again it will disappear. For changing different times, we saw that the IGV is working properly, and its opening and closing percentage is likely. Here is the 0 value, and when we applied some higher value, then it was showing some alarm or some vibration alarm. Now we shift reset and master reset apply, and this is 0. Here is force value applied. If we now we reset safety value and master reset, safety reset and master reset, then now it is okay. There is no alarm. It is now normal condition, and we followed that when we applied a force value likely 10%, then here is also output 10%, and we also saw that here is the alarm, red alarm, so it is not clear to us. And on the other hand, we saw that different value of IGV we applied. And at first we need to safety reset and master reset, and you see here the force value is applied 10%, so it is not reset. And when force value is released, then when we press safety reset and master reset, then the alarm also disappear. And now here again we tried to see the problem. When we applied 10%, then alarm comes, but it is not reset. Now again we apply 9, and again we will see it will reset or not. It is okay. That means before 10, when we apply the value, here we applied 9%, everything is okay, no alarm. You see, when the IGV driven value is greater than 9, then alarm came. Here we applied 20. So he came to a decision that after 9, the demand value, it shows alarm, and if the IGV opening or set value is lower than 10%, that means 9, it is okay.